All right. So we learned what the IQR is. It's interquartile range. It's a Q3 minus Q1. Uh, and you can use it to find outliers. So make sure that you understand that. Even if you see it in the homework online, if it doesn't say interquartile range, if he says IQR, you know it's a Q3 minus Q1. Okay, we're going to do this question. Uh, Practice what you have learned. Use your TI-84. State whether the data set in sets A and B represents sample or population. Then find the range, variance, and standard deviation of each set. Use the standard deviation to compare the variability between the data sets. Okay, wait times, guys. Let me read the title for you. It says wait times in minutes for two rides at an amusement park. Ride A and ride B data. What do you think? This is a sample data or a population data? These are the wait times of how many people? 1, 2, 3, 12. And these are the wait time of also 12. What do you think? This is a sample or a population? That should be easy to tell.
Sample.
Definitely. Because more than 12 people go on the ride. So it's a sample data. So when you find the standard deviation, guys, you look for S on the calculator and not sigma. This is one good reason why he's asking you this question. So this is ride A. This is ride B. He wants the standard deviation, he wants S squared, and he wants the range. And he wants S squared, and the range. Okay. Let's do that on the calculator, guys. We're not going to do anything by hand here. So we're going to go to stat, edit. We're going to clear the list just like I did before, and we're going to enter the data. 45, 22, 40, 48, 11, 51, 36, 55, 60, 32, 24, 37. Let's go to the second data set. 35, 50, 32, 31, 35, 45, and then I got 45, 49, 40, and then I got 43, 37, and 45. Okay, great. Let's find the standard deviation in the range of the first one. So go to stat, calc, one variable statistic, and just scroll down, guys, calc. There you go. So S is 14.5. Let's do one decimal place. And the minimum is 11, and let me show you the maximum. What the maximum is 60. So the range will be 60 minus 11, which is 49. And S, guys, as you notice, it was 14.5. We'll do S squared in a little bit. Let me do S right B now. So clear, stat, calc, one variable statistic. Now it's going to be L2. Okay, I got S to be 6.5. The minimum is 31, and the maximum is 40. Maximum is 50. So 50 minus 31, which is 19, and S is 6.5. Okay, to find the variance, guys, all you need to take 6.5 multiplied by itself. I got 42.25. And for the other one will be 14.5 times 14.5. You can tell, guys, which set has more variability already. Okay. To answer this question, guys, which set has more variability. Which ride, as far as wait times, has more variability as far as wait time? Ride A or ride B?
A.
Yeah, and why? Because it has a larger what? Standard deviation. There is more variation. If you want consistency, guys, you should go to ride B. If you want to take a chance with having to wait a lot more time than the average one person wait, or a lot less, you could be taking a chance. You go to ride A because it has more variability. So ride A has more variability because it has higher standard and higher range, guys. Look at the range, 49 minutes, and look at the range there, 19. Higher standard deviation and range. But you don't have to use the range, you can just use the standard deviation. All right. So this is how you compare data sets. The last thing, guys, we would like to do before we get into the last part of this section, I want to tell you about the the Box and Whisker plot. I don't know if you heard of this before, but let me tell you what the Box and Whisker plot is. Your calculator can do a Box and Whisker plot. This is another display of data, guys, that you learned how to do a frequency distribution table, a histogram, a polygon graph, a stem and leaf plot, and now a box and whisker plot. A box and whisker plot means what it says. You need a box and whisker toward, just the end of the box. I'm going to show you how to construct this one. Let's have this data set. Okay, this is a data set, guys. In order to construct a box whisker plot, you need a 5-number summary. Okay, so we need minimum, we need a Q1, we need a Q2, we need a Q3, and we need the maximum. Well, the minimum, guys, you agree with me, it's 2. The maximum, it's 17. Okay, let's find the median. We find the median before Q1 and Q3. The median is the value in the middle. I think this is the median, guys. It's 7. Now, Q1 is the median of the first half, which is 3. And Q3 is the median of the second half, which is right here. 10. So now I have the 5-number summary. Let me tell you how to do a box and whisker plot. You do a number line like this. What kind of numbers you need to put on the number lines? You need to make sure that the minimum shows up and the maximum shows up. So you need from 2 to 17. So this is how I would start if I were you guys. I would start like 2, 4, 6, 8, scale it properly. 10, 12, 14, 16, 18. I don't need to go beyond that because I need up to 17. So you do the number line like that. And now, for the minimum, which is 2, look what you do. Just go above the 2 and just put a dot representing the minimum, which is a 2 right here. Q1 is 3, which is halfway between 2 and 4, guys. So just go up, up, up until here between 2 and 4 and just put another dot representing Q1. 7, Q2, which is, you guys agree with me, it's halfway between 6 and 8. It's right here, watch. I need 2 more points. Q3, which is 10, right here. And then 17, it's halfway between 16 and 18. Now, The first 2 points you connect them with the whisker. The last 2 points you connect them with the whisker as well. And then you do this. Now I'm going to do the box. And that's what we call a box and whisker plot. What can you tell, just from this one? I kind of see a longer tail to the right, guys. So that probably will tell me that the data is coded right. You see there's a smaller tail on the left, but a larger one. If the box is not symmetric, like, this one is not right half in the middle, probably you can conclude that the data is not symmetric, just from the box and whisker plot. We're going to do some more exercises, but you need those 5 numbers to put them down. You connect the first 2 numbers, Q1 minimum with Q1, you connect them with the horizontal line, Q3 with the maximum with the horizontal line, and for the remaining ones, you just do those 3 vertical lines and connect them with the box, and this is called box and whisker plot. In static range, they call it just box plot. This is how you construct a box and whisker plot. We're going to do a little bit more of this later after I finish the last part. So this is the box and whisker plot. The last part. Okay, let me do this sketch, guys. Let me put the mean to be, let's say, 10, and standard deviation is 2. So I'm going to do 3 standard deviation, guys, and 3 standard deviation from this side. So mean is 10. Just to explain this to you, what is a z-score? 8, 6, and 4. I would say, guys, the 2 most important things that you should learn in this chapter, extremely important, that they're going to follow us throughout the entire semester, are 2 things: the standard deviation, 3 things: mean and standard deviation, and the z-score. You need to understand, what the z-score is, which I'm going to explain to you right now. Let's say the average score on a quiz was 10 and a student scored 12 on the quiz, above the average. Can you tell me, guys, what's the difference between 10 and 12?
2.
Okay. How many standard deviation is 2? What's the standard deviation here? Sigma is what?
1.
So it's 1 standard deviation above the mean. 1 standard deviation above the mean, guys, means the z-score is 1. So if I come to you and tell you your z-score on the quiz was 1, it means that your score was 1 standard deviation above the mean. That's what the z-score means. Now let me take 6, guys. What's the difference between 6 and 10? The difference between 6 and 10 is 4. How many standard deviation would 4 be? Each standard deviation, guys, is worth 2. So that will be 2 standard deviation. So if I tell a student that your z-score on the quiz was -2, why did I say -2? Because it's below the mean. There was a 6 below the mean, below the 10. It means that the student's score was 2 standard deviation below the mean. Now, if you score 10 on the quiz and the average of the quiz was 10, average score on the quiz was 10, your z-score in this case will be 0. So if I tell you that your z-score is 0, that means your score is exactly the average. There is an instructor who teaches statistics that in his syllabus, he explains, the distribution of the grade, just using z-scores rather than using percentages. So the z-score, guys, tells us how many standard deviation does the value deviate from the mean. How far apart from the mean is the value in terms of standard deviation. And when I write the definition of this one, and I did give you an example, just about those Z scores. I can tell you guys a Z score should not exceed 3 in most situations. And do you guys know why I said 3, not other numbers? Because we can't go beyond the 3 standard deviation. I mean, it could happen that the z-score is large, but that will be extreme. That's very extreme. The z-score should always be between a -3 and 3 because we can't go beyond the 3 standard deviation from the mean. But it does happen that you will have some extreme values that go beyond that. But normally, usually, the z-score should be confined, just between -3 and 3 and should not exceed that. So let me write the definition of the z-score. The z-score measures the number of standard deviations a value deviates from the mean. And here's the formula, guys, for the z-score. It is the value minus the mean divided by the standard deviation. And let me take you back to this example. When I took 12, guys, I told you 12 is two values, 2 points away from 10, which is one standard deviation, and I told you the z-score is 1. You don't need to think about it like this anymore. If you use the formula, look, it's going to give you the z-score right away. So what is the z-score of 12? You just put the value 12 right here, so that's a 12, minus the mean, which is a 10. So 12 minus 10 is 2, divided by the standard deviation, which is a 2. 2 divided by 2 is 1. That should give you the z-score. In the book, he writes the z-score like this. Z equals x, which is the value, minus the mean, which is mu for population, and sigma for standard deviation. Or he writes it like this, which is exactly the same formula. If you're using a sample, instead of using the simple mu and sigma, we use x bar and s. Those two formulas, guys, will allow us to compute the z-score. So it's a value minus the mean divided by the standard deviation. So just to give you an example, guys, let's say after the first test, I tell you that the mean, the average of the class was 74. And the standard deviation, guys, was 6. And then I tell a student, your z-score was 2 on the test. The student can figure out, just what his or her score actually was on the test. Look what the students can do. The 2 means that the students score 2 standard deviation above the mean. So you just do 6 times 2, which is what, the 12, and add him to the mean, which is 74. So 74 plus 12 will be 86. And that was the student's score on the test. If I tell the students that your z-score was 0, a z-score of 0 means the students had the average score, which is 74. But if I tell the students that your z-score was -1, -1 means the students score 1 standard deviation below the mean. So if a student wants to figure out his or her score, here's what they can do. They can take 74 and subtract 6, not add 6 because the z-score is negative. So 74 minus 6 would be 68, and that would be the student's score. If I tell you guys your z-score on the test was a 3.1, for example, something like that, you be sure probably your score is the ultimate highest score because it goes beyond the 3 standard deviation. That's what a z-score is. To tell us how far apart from the mean a value is in terms of standard deviation. And this is the formula for the z-score. So it's the value minus the mean divided by the standard deviation. What you're going to see in the homework online, he's going to give you the mean, he's going to give you the standard deviation, just like I did here, and he's going to give you some values and ask you to convert them to z-scores. Now, a z-score will be unusual. A value of a z-score will be unusual if it goes beyond 2, more than 2, or less than -2. That's unusual, guys. So it doesn't happen often. That's what I'm trying to say. Very unusual. Can the student guess what the number would be there? What would be the number?
3.
3. Exactly. That's what I'm trying to tell you. In real life, we confine guys to no more than 2, 3 standard deviation below or above the mean. Anything beyond that, it's way too extreme. Either high extreme or low extreme. So I'm going to add here a data value is usual, not unusual, if z is between -2 and 2. That's good. You can get between those two values, even the values themselves, just this is usual. Okay, let's do the last example. Any questions?
Can you lift up the paper?
Yes. There you go. Let's do this example, show you the power of the z-scores, how important they are. Eleanor scores 680 on the SAT mathematics test. The distribution of SAT scores is symmetric and single peaked, with a mean of 500 and a standard deviation of 100. So let me just write the SAT. They have a mean of 500 and standard deviation of 100. Gerald takes the American College Testing, ACT mathematics test, and scores 27. ACT scores follow a symmetric single peak distribution, but with the mean of 18 and a standard deviation of 6. So we have Eleanor scoring 680 and Gerald scored 27. The question is, guys, which one did better on the test? Was it Eleanor relative, just to the other students, comparing with other students? Was it Eleanor or Gerald? You can't just, guys, tell me that it was Eleanor because she had a higher score. But the criteria is different. The scores of the SAT are in the hundreds, but the scores of the ACT are in the tens, they're not in the hundreds. So how can you tell which one did better? Do you guys have any idea before we start doing this, working out, the solution? What do you think we should do?
We need to, like for the SATs, we need to do the 680 minus the 500.
Exactly. You need to change into z-score. We need to check which one did higher than the average, just with respect, just to other students. Otherwise, guys, with 680 and 27, I cannot compare. I'm just like comparing apples and oranges here. I can't. There are two different ways, just of scoring here. The only way, just to compare is to change each score to a z-score and see how many standard deviation above or below the mean each person scored. Then we can tell. So you are correct. So for Eleanor, we're going to change it to z-score equals value, which is 680, as you said, minus 500 divided by 100. And now you see how easy it's going to be, guys, once we do this. So it's going to be 1.8. Let's see what Gerald did relative to the average. Z equals 27, which is the value. The value goes first, guys, minus the mean, 18, divided by 6, which is 1.5. Now, guys, you can answer the question. Who did better relative, just to other students? Was it Eleanor or Gerald? It's the one who has the higher Z score. So it's 1.8 is bigger than 1.5. Because she has a higher Z score. So that scores the important, just of the standardized Z score because uh, once you change the value to a Z score, you can compare it, just with other values. But comparing apples with oranges like here, that doesn't work. You have to change to Z score. And I told you to find a standardized Z score for both and then compare them. The higher, the better in this situation. So 1.8 is bigger than 1.5. So this person scored better than the other one because she had a higher Z score. Okay. We're going to do some practice now, guys. This is the chapter 2 review exercise. So we'll do some practice together. I'll just go over this.
That's a quick question.
Yes.
I'm sorry, you said the higher the Z score is always the better.
Definitely.
Okay.
In the case of scores on exams, there could be some situation where lower is the better, but in this case, definitely the higher the better because the more you are above the average, the better for you as far as scores. But like when it comes, just to like debt or something else, you don't want, just your debt to be higher than others to be, better. The lower, just the better. But in most situation, yes, it is the higher the better in this case. Okay. Chapter 2 review exercises.